Hello, welcome to Maths with EJD. In this video, I'll be talking about Python control flows under scientific computing with Python. And as usual, I'm starting with this screen so you can always see the process of getting to Jupyter Notebook. First of all, I'll share my screen so anywhere I go, you can easily see. Then the next thing I'll get to do is look for Jupyter Notebook. I mean, because I always use it, I can readily get it from my search bar. And then I click on it and some black stuff comes up. That's the terminal, you know. But you don't want to ever put that off because that is what is powering what is going to come up later as Jupyter Notebook. So once that opens, you're going to see a list of documents. And then, of course, you should already know where your file is. So you navigate there. Mine is on the desktop. So I go to desktop and then I go to scientific computing with Python. And today the topic is Python control flows. That is the sixth video in this series on scientific computing with Python. Okay, so the topic is Python control flows. By the way, in case you've not seen the other videos, I have all these notes. I have them uploaded on a Google Drive, and I always have the link in the description, so you can check the description to download all the files up to this point. So, and the essence of that is that you can actually follow. So, and I always recommend that as you download the file. In fact, if you don't even download, you can open it straight on Google Drive, and to be opened in Google Colab, and then you can begin to tweak the codes. So if there's something I do, copy the code out, create a new cell, try it out and see what happens. That way you're beginning to learn. So this can actually be your gateway into the world of Python. So don't sleep on it, like they say. All right. So Python control flows is what we're talking about in this video. If you have not subscribed already, please be sure to do that. And of course, hit the notification bell so you can always get alerted whenever a new video comes. Then don't forget to comment, don't forget to like, and don't forget to share. All right. And if there's something you would like us to talk about, be it in math or Python, especially as it's related to scientific computing, feel very free to talk about it, in your comments. So Python control flows now. Scientific computing with Python relies heavily on control flow structures like if statements, else clauses, and loops to manipulate data. Of course, let me highlight uh, these things because they are really important. So I just double click on that. It takes me back to the markdown. If statements, else clauses, and loops to manipulate data, all right? To manipulate data, perform calculations, and control the flow of execution. In fact, the key thing is that control of the flow of executions, right? Now, the control flow structures are fundamental to writing efficient and readable code in scientific computing tasks such as data analysis, simulation, and visualization. So these control flows include if else, and I mean, that is if else statements and loops. Let me do this. If else statements and loops like that. So we go straight to the if statement. That's one representing if else statement, and you see how that goes as we move on. So let's talk about if statement. Of course, even in plain English, right? If tells you that there's a condition attached to what you're talking about. It's conditional. Okay. So if statements are used to make decisions based on conditions. So you set some conditions and then then whatever you're doing is going to be executed based on the conditions you have set. So if statements actually allow your program to execute certain blocks of code only if certain conditions are true. For instance, in example one, so we have a simple if statement. So it only deals with if here. For instance, you say x is equal to 10. That's an assignment statement, assigning 10 to x. So if you now say if x is greater than 0, print x is positive. So if I click on that now, it just tells me x is positive because 10 that you have there is greater than 0. So what if I do another example? I mean, uh, if you like, you can call that example 1a. Let me just call it that. Example 1a. And I said, now this is x equals minus 4. And then I say if x is greater than 0, print x is positive. If I click on this, no result because I did not make room for negativity. So, but then if I change this now to if x is less than 0, print x is negative. So that one did not give you an answer because -4 is not greater than 0. So I did not tell it to do anything. So, but now if I change it to if x is equal to -4, I mean x is equal to -4, if x is less than 0, print x is negative. Now, because x is -4 and it is less than 0, it prints x is negative. Okay? So let's take the second example. Now, at first we had an if statement. Now let's look at an if-else statement. So if you have just one condition and another, if you have two conditions, right? One takes if, the other one takes else. So if you have just one condition, you use an if statement. If you have two conditions, you use an if-else statement. Because if the first condition doesn't hold, then else the second one will hold. For instance, temperature is 25. Then you say if temperature is greater than 30, print it is hot outside. Else, print it is not too hot. Now, take note of all these indentations. Anytime you have a conditional statement like this, the next line is going to come like four spaces under the first line because it is considered to be under the if statement. Very important. All right. So if temperature is greater than 30, print it's hot outside. Else, print it's not too hot. So if I click on this now, because 25 is greater than 30, I mean, because 25 is not greater than 30, rather, then it says, if I had a number greater than 30 to say it's too hot out, it's hot outside. But because 25 is less than 30, it just tells me it's not too hot. So if I copy that out, create a new cell, paste it, and call it example 2A, call it example 2A. And what I have is 36 degrees, as it's very common in Nigeria, right? Example 2A, if else statement, so temperature is 36 now. If temperature is greater than 30, print it's hot outside. Then else, print it's not too hot. The first example we had it's not too hot because 25 is less than 30, but now 36 is greater than 30. So it's going to say it's hot outside. So it follows those conditions. Okay. Look at example 3. We have a simple grading system. So we have grade equals 85. That's you assigning that grade to it. So if grade is greater than or equal to 90, then that is A. Else, now, if you have, if you have one condition, that's an if statement, you use an if statement. If you have two conditions, you use an if else statement. But once you have three or more statements, you use if for the first one, you use else for the second one, elif for the second one, and you use else for the last one. In fact, if you have more than three, like say you have 20 conditions, so use if for the first one, then you use elif for every statement in between, and then use else for the last one. So if for the first, else for the last, and elif in between, no matter how many number of conditions you have. For instance, in this case, we have four conditions, A, B, C, or fail. All right. So because it's four conditions, like right, use if for the first condition, use elif for the next two conditions, and else for the last. So don't forget if first, else last, elif for everything in between. You get that? So if grade is greater than, if, okay, grade is 85, then if grade is greater than 90, greater than or equal to 90, print A. Elif, elif is actually short form for else if. You find else if, I think, in MATLAB and maybe some other programming languages. So, but in Python, it's pretty easier. Elif, so you don't have to type else if. So elif grade is greater than or equal to 80, print B. Elif grade is greater than or equal to 70, print C. Else, print fail. That is, if you have four conditions, once the first three conditions are not met, you don't have to clearly spell out what should be met for that. It means anybody who scores less than 70 actually is fail. Actually fails, right? So if you click on this now, because this is 85, and 85 is not greater than 90, so it won't be A. But 85 is greater than or equal to 80, so it will be B. So if you run this now, the result is B because it's 85. Now, things can even get more interesting. What if you want something, like you just want to write a code that requires whoever is using it to impute a value and then get a grade based on that? So here I've put the Nigerian grading system for undergraduates, right? At some point, it used to be A, B, C, D, E, F, but these days just A, B, C, D, and F is skipped. And the condition is that if you have 70 upwards, that is an A. If you have 60, if you have from 60 to 69, that is B. If you have from 50 to 59, that is C. If you have 45 to 49, that is D. Then anything less than 45 is F. All right. And in this case, I've actually made it like a statement. Instead of just writing me, I say your grade is this based on whatever score you enter. So this line now, this first line, very important. Okay, I can put line numbers. I just go to view and I say show line number so I can refer to. So in line 3 now, this is where so I'm writing that so that you can receive values. So and for you to receive values, you use this input statement. So just say input, enter your score. And then I need to clearly define the kind of value I wanted to put. So here I said you should put float. It means that now you can use decimal numbers. Don't forget the variable types in Python. They are integers, float, point, arithmetic. That's integer is whole number. Float is anything involving decimal, and then of course you have the other one. So whatever you're putting there, you are very free to put maybe something like 70.0, 68.6, or something like that, because it's float here. If I make it integer, then I'm constraining you to not put any decimal part. So, and then I put the Nigerian grading system. If you score greater than or equal to 70, your grade is A. Elif greater than or equal to 60, your grade is B. Elif score, I mean, I'm using score here, not grade, sorry. Elif score is greater than or equal to 50, your grade is C. Elif score is greater than or equal to 45, your grade is D. Else, your grade is F. So you see that for else now, I don't have to say, I don't have to say else score is greater than or equal to something. I don't have to say that. Once all the other conditions have been excluded, whatever is left, you just go straight and say else. You just print whatever grade is assigned to whatever condition has not been met so far. So in this case, you're at liberty to input your own score. So I click on it, it says enter your score. Now this enter your score is what I put here for the input statement. And then because it is float, I'm free to put decimal. So I can say you are free to put 70 because it's also acceptable. If I say 70, it tells me my grade is A. I can run it again. And say 69.9. Enter. So 69.9, as close as it is to 70, it will still B, right? Then I can run it again. And then I put, say, somebody gets 37. That is, your grade is F, something like this. So I go again, I run that again, and I say, maybe I got 100, that is it. Okay. So you can actually make it open-ended like that, such that whoever is using it is free to put their own value. Just like what happens at the ATM when you go to collect money from the ATM, everybody is at liberty to impute their PIN because it's your private access to your account. Okay, so that's it about if statements. In fact, I think it's better to call it if else statement. Let me put it that way now. So elif, elif else statements. So one condition, if, two conditions, if else, three or more conditions, if elif else, like that, as you've seen already. So that takes us to the idea of loops. A loop is like something that keeps happening, and that is the kind of idea we also have here. For instance, loops are used to repeat a block of code multiple times, and they are crucial for iterating over data structures, performing repetitive tasks, and implementing algorithms. So while and for loops are two common loops in Python. So we are going to look at while loop and for loop. So while loops repeatedly execute a block of code as long as the specified condition is true. For instance, you have example 1, a simple while loop. So count is equal to 0. That is what that you can call initialization. It's like you're assigning 0 to that thing first. Though it is going to take some other values later, but at first you're initializing it to be 0. So you now say, so count equals 0. So you now say while count is less than 5, then print count. So this is you wanting to count now. So once, as far as whatever value you have is less than 5, then you print the count, and then you now see this count plus equals. Now plus equals means that whatever the first count you have, so add 1 to it, and you go next. So for instance, if you come here with 0, you see count is less than 5, 0 is less than 5, then you print 0, and then you come to count plus equals 1. That means add 1 to that 0. That's 0 plus 1, 1. Go again. So you have bring 1 here. So it means your count now is 1. So you now say 1 is less than 5, you print 1. And then you come here 1 plus 1, 2, go again. 2 is less than 5, you print 2. And then you add 1 to it, that's 3. 3 is less than 5, you print 3. And then 3 plus 1, 4. 4 is less than 5, you print 5. Then when you 4 plus 1, 5. 5 is not less than 5. 5 because 5 is equal to 5. So then it means you are only going to print from 0 to 4. That's what this is going to give you, as you can see. So when you run it, you get 0 to 4 because you start from 0 and you keep counting until you get to a number that is less than 5. And that number is 4. That's why you only get to print 0, 1, 2, 3, 4. So imagine you want to count from, okay, I can just copy this out, create a new cell, and count something bigger. Like let's maybe we just want to count from 1 to say 50. So I want to count 1 to 50. So that I say count equals 1, and then I say while count is less than 51, print count. So it means this is going to count from 1 to 50. So if I run that, you see it's count from 1 to 50 like that. Now you can see I'm imputing this myself. So that's the kind of thing I expect you to do. So once you download the document or you open it in Google Colab, copy out whatever you have and just tweak the codes, play around the codes, and from there you get insight into how they function. Okay. So let's go to, okay, this, I can call this example 1A. That's like my Jara, my extra on this. All right. So example 2, you want to print all odd numbers less than 50, all odd numbers less than 50. Of course, the first odd number is 1. That's your initialization right there. So 1, that's the first odd number. So you now say while I is less than 50, because we want to print all odd numbers less than 50. So you don't want it to be 50 or more. So every odd number less than 50. So I is 1, while I is less than 50. So you bring 1 here, 1 is less than 50 for sure. Then you print that 1. Then you go to the next line. What is happening here is you have I plus equals 2. That means that I you have brought, which is 1, add 2 to it. That's 3. You take 3 back. 3 is less than 50. You print 3. 3 plus 2, 5. 5 is less than 50. You print 5 and you keep going like that until you get all the odd numbers less than 50. So if I run that, you get 1, 3, 5, 7, 9, 11, so on until you get to 49. All right. That's how that works. Okay. The example 3 here, using the while loop for countdown. So imagine you want to count down like, you want to count down to a race or you want to count down to whatever, you can actually do this here. So say you want to count down to 5, all right? So now say while countdown is greater than 0, as far as the countdown is greater than 0, then you print the countdown. And then since you're counting down, right, you are going to have a constant reduction. So you now say countdown minus equals. So this minus equals is a very efficient way for Python to keep subtracting instead of, maybe in some cases you may have to do some more complicated stuff. But as far as Python is concerned, when you say countdown minus equals 1, that means whatever you bring, subtract 1 from it and, keep doing that as far as the process goes on. And then once, while countdown is greater than 0, so it means if you get to a point where, if you get to 1, 1 is still greater than 0, so it is going to print it. But when you get to 0, 0 is not greater than 0, then it will just blast off automatically. So if I click on this now, it just says 5, 4, 3, 2, 1. Now the blast off didn't just come. The blast off came because by the time I took 1 here, 1 minus 1 is 0. By the time I bring countdown is now 0. So I say 0 is not greater than 0. That doesn't work. Then if that doesn't work, then you just print blast off. Okay. So you can count down like that. All right. So another example, using while loop to find factorial. Factorial is, if I say 10 factorial, that means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you start from that number and you keep multiplying it with integers less than it until 1 less than it until you get to 1 finally. Okay. And it's a very simple while loop to take care of that. So imagine if I need 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. So that's 1, and that is supposed to be 120. So num is 5, factorial is 1. So you now say, well, num is greater than 0. So you keep going until you get to 1. So because whenever you say num is greater than 0, it means the 1 is the last number that qualifies to be greater than 0, because once you get to 0, then that stops. So here now, num is 5, factorial is 1. You now say factorial. Multiplication in Python is this star, like we already saw under basic Python operations. So star equals means simply you bring factorial, all right? So the factorial here is here as 1. Then you have 5, of course, is greater than 0. So you now say factorial times the number, that's 5, okay? And then you bring it down here, num minus equals 1. So that's 4. You take it back, num is greater than 0. Then you now say that factorial again, whatever factor. So, the new factorial now is now the 5 you had already. So you bring it back, that's 5 times 4. So the new factorial is now 5 times 4, right? Then the next 5 times 4 times 3, and it keeps going until you get to 1, and then that gives you 120. Okay. Uh, Another thing you could actually do is you could print, you may want also choose to print each value. You want to print each factorial as it goes step by step. So in that case, I just add print factorial to line 6, and then it can show us. So it says, the first one is 5, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. And finally, even, so I can actually put, I can come here and put a blank print to space that out. So if you want to see it as it's going step by step. So this print factorial is what is showing me the step-by-step thing that is happening. And then the final result is this factorial. I guess that is pretty sweet. So please, download the documents, check the description, download the documents, and try your hands on these things. They are very sweet to interact with. So we come finally to the for loop. For loop. We've dealt with while loop. Now, whatever for loop can do, while loop can do also. But the only thing is that for loop is like more straightforward. It's like it gets the job done with less noise, compared to while. Okay, so whatever while can do, for can do too, you know. But the thing with for loop is that for loops iterate over a sequence such as a list or a tuple or string or even a dictionary. Well, I'm not sure. Maybe a set also, and it execute the block of code for each item in the sequence. So for loop now, you are going to give it a range or a set of elements to operate on until it gets to the end. So it's not like, of course, the while thing gets to the end when the condition is finally met. So here now, you have simple for loop. And here you have, of course, this is with a square bracket. So that is actually a list, a list. So you have a list of numbers, 1, 2, 3, 4, 5. And now say for num in numbers, print num. So now for num in numbers, print num. So this num is just like I like to call it an index, or I don't know if it's good to call it an indexer. So it could actually be anything. So for num in numbers, print num, that means first number, print it, second number, print it, third number, print it, and until you get to the last number. So that will just print 1, 2, 3, 4, 5. Now for you to show you that that num is actually an iterator, so it could be anything. So I can actually say for I in numbers, print I, it will give me the same results, So that num is just, it's not, it can be anything at all. But the number is actually referring to that list. So don't forget that. Yeah, like you can use anything for your index. So look at example 2. You can actually use a range function instead of spelling out the numbers. For instance, imagine I want to do a task from 1 to 1,000, I want to do a task from 1 to 1,000, that's a lot. So instead of having to write as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 1,000, that's so much stress. So instead of doing that, I can just give it a range. I just say for I in range 5. Range 5 means, now don't forget, counting in Python is from 0 upwards. It starts from 0. So, and and it stops a step short of what is specified. So for I in range 5 now, so it means it's going to print 1, 2, 3 and stop at 4, as you can see now. So start from 0, or 0, 1, 2, 3, 4. So it doesn't get to that 5. If you want to get to 5, you have to put 6 there. So just like I said, you may not appreciate it printing from 1 to 0 to 4 because it's short, right? What if I want to print all numbers from 1 to 500? Imagine me having to write the list of and say 1, 2, 3, 4, 5, 6, 7, 8 up to 500. That's a lot of energy. But by just saying for I in range 500, print I. So it means it's going to print from 0 to 499. And as you can see, so it's printing from 0 to 499 in just a blow. Imagine the time it takes for me to do all this. If I wanted to list from 1 to 499, I wouldn't have finished. But I mean, you have this range to cut that time for you. And that's so interesting to relate with. Okay, so let's go to another example of for loop. Example 3 talks about nested loop. A nest now, something is inside something. So a nested loop is a loop inside another loop. For instance, for I in range 3, that means for I starting from 0 to 2, that's 0, 1, 2. And so for I in range 3, that's the first loop. And then under that loop, you now have another loop again for J in range 2, that's 0 and 1. Because range 2 means 0 and 1. You don't get to the 3, you don't get to the 2. You start from 0, but you stop a step short of what exact number you have. Now, for all these two, now you don't want to print all the possible combinations. So that means you have for I in range 3, that's 0, 1, 2, right? So for instance, if you pick 0, so you hold the 0, and then here it's 0, 1. So you have 0, 0, 0, 1. Then once that is exhausted, you go back, you take 1. So you have 1, here, it's like you have okay, this is how it looks like. Let me just put this in comment. This is how this actually looks like. So it's like this is a list of 0, 1, 2. And then this is a list of course, we make comments in Python using hash symbol. So don't forget. So for J in range 2, that is 0, 1. So that means you want to do like a Cartesian combination, right? So you pick 0 here. So that'll be 0, 0, 0, 1. Next, you have 1, 0, 1, 1. Next, you have 2, 0, 2, 1. And that's the kind of thing you're going to get here. If you say print, this is actually what you call an F string. So whatever I you pick and J you pick, it's going to have the combination of the two here. And then you have those combinations. And the combination will usually be the number of elements here, that's 3, multiplied by the number of elements here, that's 2, making 6. That's why you have 1, 2, 3, 4, 5, 6. So that's what you can call it, like a Cartesian product, right? So pick 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. And that's exactly what you have here. So that's a nested loop, a loop inside a loop. So now, can we use that idea for a multiplication table? Imagine you need a loop to print 12 times table, like 12 times 1, 12, 12 times 2, 24, 12 times 3, 36, up to 12 times 12, 144, something like that. So you have for J in range 1, 13. So of course, you know what range is about, right? So for J in range 1, 13, what okay, yeah, 1, 13 here because you don't want 0 showing up. That's exactly why we are doing this. We don't want 0 showing up. That is why we are doing this. So for J in range 1 to 13, if I wanted 0 to show, I'll just remove the 1 and then it start from 0 to 12. But I just want 1 to 12. So it start from 1 and then it stops at 12. So for J in range 1 to 13, what do we have? We have result is 12 times J. So it means, so since I want a 12 times table, the 12 is fixed. So what will be changing is the J, which is 12 times 1, 12 times 2. So what you are printing here is 12 times each value of J that is taken. So you have 12 times 1, you get the result. 12 times 2, you get the result. 12 times 3, and that goes on until you get to 12 times 12. If I run that, see what you get. That's 12 times 1, 12, up to 12 times 12, 144. Okay? Now, things can actually get more serious, right? What if I want to print from 1 to 12 times table? That means I have 1 times 1, 1, 1 times 2, 2. I mean, 1 times 1, 1 times 1, 1, 1 times 2, 2, 1 times 3, 3, up to 1 times 12, 12, and then I go 2 times 1, 2, 2 times 2, 4, up to 2 times 12, 24. And then I keep going like that until I get to 12 times 12, 144, like that. That's a big deal. But of course, in just 1, 2, 3, 4 lines of codes or 5 lines of codes, you have it sorted. And what is happening here? We need a nested loop for that. So because we have, you have from 1 to 12 for one, you have another 1 to 12 for the other one. So for J in range 1, 13, and for K in range 1, 13. So this loop is inside that loop, a nested loop. So here we now want to print result equals J times K. So it means if you pick 1 here, you run it over, then you run it over the K. So that's 1 times 1 to 12. Then after 1, you pick 2, 2 times 1 to 12, up to when you get to 12. So you pick 12 here, 12 times 1 to 12. And then you have this long thing. So here, this is what the statement to teach you're printing. So print using an F string. What makes it F string is this F outside here. So you can put your J and K, and then you have the result. And then you can print all that. So this print that is here is actually creating a space between each times table. If you, after doing 1 to 12, 1 times 1 up to 1 times 12, you have a space. That's what this line 7 is doing for you. So if you run that, you have everything spewed out in just a split second, you see? So you have 1 times 1, 1 up to 1 times 12. You have 2 times 1 up to 2 times 12. You have 3 times 1 up to 3 times 12. Then you have all of that. You have 12 times 1 up to 12 times 12. So, I mean, with this, it's so easy. You can just generate these things so fast. Okay. Next, we have using for loop with dictionary. When I was talking about Python variable data structures, I didn't bother about dictionary because, like I said, we are not going to be using it so much. But I mean, this is an opportunity to relate to the dictionary because a dictionary is a value it's a key value pair. So you have a key and you have a value. So in this case now, this is a dictionary. Dictionaries are defined using braces. So this is a dictionary named student grades. So Alice is the key. The value assigned to Alice is 85, which is Alice's grade. Bob is the key. The grade assigned to Bob is 70. Charlie is a key. And the value assigned to it is 95, which is Charlie's score. And using a for loop, now we can now say for name. So you now say for name and grade in student grades dot item. So you're referring to each item in this dictionary now. So for the name and the grade, right? In student grades dot items. So what do? You print, use an F string, you print the name, and you say the name's grade is whatever the grade is. So name and grade, name is assigned to each name and grade is assigned to each grade. And then this dot items is what retrieves those things out of the dictionary called student grades, right? And then you print the name and the grade together. So it means this is going to be Alice's grade is 85, Bob's grade is 70, Charlie's grade is 95. And when you run that, that is what you get. Cool. And then we have example 5, using for loop with list comprehension. For instance, you can do a set of calculations over a wide range. For instance, you want to square every item, every number in a list. For instance, we have the list 1, 2, 3, 4, 5. I want to square all the numbers. So all we just do is we just say squared numbers equals num raised to power 2. This num now is now your index. So you now say num raised to power 2 for num in numbers. So it means it's going to square each of the numbers here, and then it is going to print it out. So for 1, 2, 3, 4, 5, we now have 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 5 squared and 25. So you can do all that kind of thing, you can actually get to do that. Okay. So okay, I feel like doing something. Let me take this again and just create a new cell, and I have this here. Maybe you want to make this into an equation, like what you do when you plot a graph, right? So let's say here now, maybe want to map this. These are your x values. Maybe I can even start from 0. Like you want to plot a graph. Let me start from minus, like when we plot graphs, you have -4, or let me start from -5, -5, -4, -3, -2, -1, 0, then 1 to 5 again. So, you have the x values, you want to get the y values. So I just say, maybe I can call this, say, okay, let me just call this x, these are x values. And then I call this one, okay, instead of just calling it x, let me say x values. And here I say y values. Y values. So for the y values now, I can now say that, so I can say maybe the equation is x squared plus 5x plus 6. That means each value of x. So I can say x squared plus 5 times x plus 6, x squared plus 5 times x plus 6. Then since I've picked this x now, so I have to say for x now in x values, for x in x values. So it means our index is x. So it means each of these items is going to be like our x. So we now say for x in this in x values, and then at the end of the day, we want to print y values. Or we can actually print, we can do the kind of thing we did before when we're printing pairs of values. Say, yeah, something like this. So I can just come and print pairs of those. So I can just say print, I can say, okay, let's just go, and I have this. So I just say print F, then we just have, so I can just have X here. I can have X here, And then here I have Y values. I hope that works. Let me try that and see if it works. Yes. No, not quite, not quite, not quite. It's not working as I expected. It should work. Let me see this. Let me see this. What can I do with this? Mm, no, no, no. Okay, let me just print Y values. Let me just print Y values. But it should work. So you have X. Okay, maybe for X, I should have this too. For X, then I have this following. Okay, maybe this should work. Okay, so it takes X. For X, mm, okay, that's not working as I expected. So let me just print Y values, right? So let me just print Y values. Print Y values. Y underscore values. I think that should work. Yes. So that's just mapping stuff to it. So minus 5 squared is 25. 25, 25 plus 10, right? 25 plus 10 is 35. 35 plus 6. What's happening? Okay, yeah. Okay, minus 5 squared is 25. Then 25 minus 10. 25 minus 10 is 15. And 15 plus 6. I guess something is not working good here. What's happening? What's happening? What's happening? Mm, did I do something wrong? Let me put this in brackets. I guess something might be evaluating wrongly. Yeah, let's hope this works now. Okay, same thing. This is 25 plus 10. 25 plus 10, that's 35. 35 plus 6. This is x squared. Okay, maybe I should use a simple formula. Let's just do 5x plus 6. Let's see how that works. Okay, I think this works better. Um, Maybe something is wrong with that. I don't know. So 5 times 6, that's minus 25 plus 6. That's minus 19 as expected. Let's jump to say minus 2. Minus 2 times 5 is minus 10. Minus 10 plus 6. Minus 10 plus 6 is minus 4. Okay. Okay, I think this is expected to be minus 1, right? Let me do that again. Minus 1. Okay, we have that. And then the last one, 5 times 5, 25 plus 6, 31. So that works. So I mean, to do the other one, I think I need to figure something out. Okay, so lastly, we have example 6, print. Okay, this is like example 5A, right? Example 5A. So example 6, print the elements of a list. There are fruits, apple, banana, and cherry. This is like a list now and of strings. And then you can say for X in fruits, print X. Or you can say for fruits in fruits, print fruits. Anyhow you like it. And that works. So that's it. Thank you for coming along this far. If you have not subscribed to this channel, be free to do that and hit the notification bell so you can always get alerted whenever a new video is released. Then, of course, don't forget to comment, like, and share because there's a lot of value you can get from here. So, see you in the next video. Thank you.